my channel, STEM Cafe, where I make everything science, technology, engineering, and mathematics easy to comprehend, assimilate, fun, and entertaining. We are still on series, and today we are handling power series. When we are talking about power series, we are talking about a series where we arrange it in ascending or descending powers of x, but most times it's in ascending power of x, to express certain functions which seemingly they are related, but in mathematics we find a way to connect them. Like when we say, okay, we have sin x, I want to express it in terms of x. You know, it's not that easy to connect. We have sine generally from this place, opposite, hypotenuse, and this is the angle we are talking about. And we are now saying that sin x is equal to opposite over hypotenuse. You know, this is a ratio. Now, I'm now saying that I want to make an expression where once I put x, it's going to give me this. Just like saying, okay, I want to put in a ratio inside an expression to give me density of a material. You know, it's very hard to connect, but in mathematics, we find a way to connect sin x and x. Let's see how it is done. Look at this expression now. I say fx is equal to a plus bx plus cx squared plus dx plus e x raised to power 4 plus f x raised to power 5. You can see this is how power series looks like. Our main function now, or our main work, is to get what these coefficients will be, for us to get this, to relate this function and this expression. Now, you know, now if I want to get the value of a, it's very easy. I just put 0 in all this space, and I will get the value. Once you get the normal value for f when it is 0, I will get that one. Let's assume I have sin x. You know, I want to express it like this. I'm going to have a plus b x plus c x squared plus d x cubed plus e x raised to the power 4 plus f x raised to the power 5 plus. You understand? Now, if I substitute 0 inside this expression, what does that give me? It means that all these ones behind will disappear. All these ones will disappear. And I will have a left in this place. Yet, I have to put 0 here also. Now, let's do that. Substitute. Zero. So what does that give me? X sine 0 gives me a plus b into 0 plus c into 0 squared plus d into 0 cubed. You get that? And why do we call it power series? I think I explained before that this is arranged. It's like we express it in the powers of x. That's why we call it power series. Now, since I have sin 0 to be equal to this, 0 will be equal to a. So let's find the place of putting our values. So a equals 0. And let me call this 1. Let's call this one expression 1. Now, I have known what a is. How can I know the other coefficients? After thinking very well, you know, the mathematicians, when they were discussing, joking, somebody just suggested differentiate. And when they differentiated, they realized that the constants will disappear. And from there, they can still work it out again. Let's differentiate 1. And how does that go? We have cos x is equal, it's identified as a disappears, d plus 2cx plus 3dx squared plus 4dx cubed plus 5f x raised to the power 4. Now, let's substitute 0 in this place again. Now, let's substitute 0 for find this, let's differentiate 2. So I'm going to have minus sine x, and that will give me 2c plus 2 times 3 x plus 3 times 4 ex squared plus 4 times 5 fx cubed. So let's call this 3. Now, let's substitute 0 in this place again. So what do I have? I have this one to be 0, 2c plus all these other ones to be 0. So which means that c equals 0. So let's have it. Now, let's repeat the operation again so that these other ones will show by differentiating 3. That's going to give me minus cos x. This one disappears. We're going to have 3 plus 2 x plus 3 4 times 5 fx squared. Let's call this 4. You can see the sequence. Let's substitute 0 for x here again. So this will be minus 1, and this is 2, 1, 3. All these other ones will give us 0. So what does that show us? It means that d is equal to minus 1 over 2 times 3. So, minus 1 over 2 times 3. Now, as we did before, let's differentiate the expression, this 4. Let's differentiate it. Now here. So what do I have? Minus, okay, this one will be sine x because it's minus. Sine x gives me, this one disappears, 2 times 3 times 4 plus 2 mx. Now what? Let me substitute 0 for x. So we have sine 0 will be equal to 2.3 minus 4 e. This other one will be 0 because they contain x. So what is sine 0? 0. So e equals 0. Now let's see what f will be by differentiating. Okay, let's call this one 5. Differentiating 5. Now we differentiate 5. What are we going to have? We are going to have cos x equals 2 times 3 times 4 times 5 f. All these other ones will contain x. And what is? Let's substitute 0 for x. So we have this one to be 1 is equal to 2 times 3 times 4 times 5 f. 0, 0. So what does that mean? It means that f is equal to 1 over 2 times 3 times 4 times 5. So f equals 1 over 2 times 3 times 4 times 5. You can see. Now, we will now plot in or substitute these values for the coefficients in this expression, in the first expression, and let's see how it goes. Now let's put here. Therefore, sine x can be written again as 0 plus x c plus 0x squared. What is d? Minus 1 over 2 times 3 x cubed 0 x raised to the power 4. What is f? Plus 1 over 2 times 3 times 4 times 5 x raised to the power 5. And it goes like that. So, let's write it out very well. So, sin x can be written as x minus 1 over 3 factorial x cubed plus 1 over 5 factorial x raised to the power 5. So, you can see it's mixed series with the powers of odd, with odd powers. See this one, positive, negative, positive, negative will be there next. So that is how, what's it called? So which means that the next one will be x raised to the power 7 over 7 factorial, x raised to the power 9 over 9 factorial. You can see the fun in this power series. So anyone you want to do, this is how you just go about it. You first of all express it as this, and then you will be using differentiation to find the coefficients. Knocking off some, finding some, after substituting 0 into the equation. Now, this leads us to Maclaurin series. Now, under the Maclaurin series, instead of first of all writing it out as a power series with increasing power of x, we just come straight to the point. And if you can differentiate and substitute 0 into each expression, you can come straight to the terms. So under Maclaurin series, instead of first of all writing it like this, fx equals a plus bx plus cx squared, we don't need to do that. In this place, it has already told us what the coefficients are. So we don't need to start working out what the coefficients will be one after the other. So he has already worked it out and he has already put it there. That is what we tried to get in the first time. That's what we tried to get when we are working the power series. But now Maclaurin has made it so straight for us by writing it out for us. Straight. I will show you how it is derived. I will show you how it is derived. Look at this first one. You know, we said fx equals to a plus bx plus cx squared plus whatever. But he has told us that the first one, a is going to be 0 imputed into the series. You understand? For the second one, it is the first differential of the expression fx, where you substitute 0 for x and then you multiply by x. This is d. C. This is the second differential. And then you put in 0 inside the second differential. You multiply by x squared over 2 factorial. The third differential over 3 factorial multiplied by x cubed. And it goes on like that. That is what we did in the first place. Let me show you. So when we have fx equals a plus bx plus cx squared plus dx cubed plus e x raised to the power 4 plus. You know, I wanted to get this, the a, we substitute 0 for x here. So we said fo is a, and all this other one is going 0. So that's what we have here. You understand? That's what we have here. Now, when we differentiate this expression, we are going to have fx. A disappears. Plus b plus 2cx plus 3dx squared plus e 4ex cubed plus. Now, if I want to find b, I put 0 here. So I am going to have f0 equals to b plus, you know, all these other ones become 0. So that's how we got this. Do you understand? So, for the next one now, let me do it. I differentiate this. B disappears. So I'm going to have 2c plus 2 times 3dx plus 3 times 4ex squared plus. You understand? Plus. And then, this one will be 0. You can see, all these other ones become 0. So which means that c is equal to over 2 times 1. That's what I have. See. Can you see? So he has made this straight for us. All you just need to do is, once you have this relationship, the next thing you need to do is just to be differentiating fx over and over and over, and be substituting 0 inside your results. So if I am given something like to find the series express like a cos x in series. Now let's look at this. It says expand 1 cos x 2 sin square x as a series of ascending power of x. That's the ascending power. That's why we call it power series of x. Now since you have already seen Maclaurin series, all I just need to do is to say, okay, fx cos x. The next thing I do is differentiate this and put 0. So that's the first one. That is 1. The next one is this. I differentiate fx. That is minus sine x, isn't it? So sure. So the next one I'm going to have now see, I am differentiating over and over. And that is 0. That is 0. So what do I have here? So I have now, etc. Now let me now put it here. Let me now use this expansion to work it out. Therefore, cos x. What is f(1)? That is 1. What is the first differential? 0. The next one, minus 1 x squared over 2 factorial. For the third one, 0. The fourth one will now be x raised to the power 4 over 4 factorial. And that is 1. The fifth one will not be there. So that's how it will go. So after this, the fifth one will not be there. So the sixth one will be negative. And by reasoning, that will be x raised to the power 6 over 6 factorial. The seventh one will not be there. The eighth one will come. X raised to the power 8 over 8 factorial. You can continue. You can do this as in differentiate as many times as possible so that you'll be sure of the expansion you are doing. You can see, instead of, like, it makes the job easier and shorter using Maclaurin series. It is a shorter form of working out the power series. Now let's look at the second one. Now if I want to do for that of sin square x, I just do fx sin square x. So f o sin square 0. That's 0. So when you differentiate, that's going to give us 2 sin x cos x, which is sin 2x. And then f will be sin 2 into 0. Sin 2. And that is 0. So this is what you need. The 0 of the differentials. That's what you have to get. So if I put 0 here, it's going to be 1 times 2. For the next one, it's going to give me minus 4 sin 2x. And what does that give me? 0. After this, what do I The next one will be okay. 16 sine 2x. That's 0. Let's do it to 7. So x6. That's it. The next one, let's do it to 7. Minus 64 sine 2x. That's 0. Now, you know the expansion now. F0, xf, xf, hash 0, second differential, third differential. Now let's now put it to use. So what does that mean? It means that sine square x can be expressed again as, what is the first one? 0. The second one, 0. The third one, what is the third one? 2. Okay. 2x squared over 2 factorial. The third one is 0. The fourth one, minus 8. Minus 8. X raised to power 4 over 4 factorial. Fifth one. Sixth one. 32. X raised to power 6 over 6 factorial. And it goes on like that. I don't know if it's 0. The next one is 64 and whatever. So, this is what we have for sine square. Now let me write it out clearly. So let me write it out clearly. I'm going to have it like this. Sine square x is equal to 2. So that will be x squared minus 8 4 factorial. That is x raised to the power 4 over 3 plus 8 is 24. The next one will be 32. Let me see. 32 over 6 factorial. Okay. Plus, let me see that one. So, 32 over 6 factorial is 2x cubed. And 2x raised to the power 6 over 45. So this is the expression for sine square x. Sine square x. This is the expression for sine square x. So, you can see how we have been able to use power series to work out the expression for cos sine square x and whatever. So it can be used for so many ones, which we will do in our exercises later. And all I just advise is learn this by proving it, by working it out. There's nothing to prove, and then learning it or memorizing it. Like this one, just write fx. You start by fo, differentiate this once. Okay, let me put x before it. You can see. Divide. This one is what you should be considering. The number of times it is differentiated. Then x squared here, 0. Remember, over 2 factorial. Then x cubed over 3 factorial. 1, 2, 3. 0. And it goes on like that. You can see, very easy. He has made it very easy and straightforward for us. Now, let's look at another one called Taylor's series.